We are discussing the first part of modern physics today, that is atomic physics. In fact, from atomic physics, you can expect 2 questions in the final examination Eamcet. Before taking up the topic and some of the applications of this chapter, let us once again take up the important formulae of this particular chapter as such. Atomic physics is consisting of cathode rays, then photoelectric effect, then X-rays, then we have Compton effect and de Broglie's hypothesis. These are the major 5 parts or 5 different topics we are going to have in this chapter, atomic physics. Let me just remind you the important formulae regarding the very first one, that is cathode rays. What are the important equations for this? The very first one is, whenever a charge, that is an electron of charge E and mass m, enters into an external electric field of strength capital E, then the force it is going to experience in that particular electric field is going to be E into E. And of course, you can understand the next concept over here, acceleration of this particular electron, which of course can be taken as F by m, that now can be written as E by m. So this is a pair of equations we have to remember as far as the influence of external electric field on the moving electron that is concerned. An electron of charge E and mass m is entering an external magnetic field of induction capital B with a velocity v, making an angle theta with the direction of the field. Then what is going to be the force it is going to experience? F is equal to BeV sin theta. That is the formula. Of course, you can understand from this, if theta becomes 0 or even 180, you can directly understand the value of F being minimum and its value will be 0. If at all I consider theta as 90 degrees, then of course we can say sin 90 being maximum, the force over here will be maximum and its formula will be BeV. So once again, if you want acceleration, that force by mass you can directly add. So that is the second formula you have to remember. Coming to the third one, when an electron of charge E, mass m, is entering into an external field of potential difference V, then of course the energy gained by this electron in the form of kinetic energy, that is equal to EV joule. That of course you can write from this one, velocity with which the electron is entering into the field, that is 2 EV by m under root. This is another formula which one has to remember. In fact, based on these equations only, E by m of an electron has been determined by Thomson in his experiment. That of course E by m, in what way we have taken up? In terms of magnetic field, when I write BQV, that is BeV, is equal to E into E. When the force due to magnetic field is equal to force due to electric field. Suppose if I consider this one as a condition for undeflection of this electron, E getting cancelled, V will be equal to E by B. This is one more formula to be remembered. And of course, centripetal force BeV is equal to centrifugal force mv square by r. V getting cancelled, E by m now will be V by Rb. In other words, E by Rb square. This is one formula by means of which E by m of an electron can be determined using the concept of magnetic field and its influence. What about the field influence of electric field, please? We have already discussed about the concept of EV is going to be half mv square. So you can even write E by m is equal to V square by 2V. V square can be written as E square by B square. So 2B square V. This is another formula by means of which E by m of an electron can be determined. So as far as cathode rays are concerned, these are the possible formulae one should remember. And coming to the second one please, that is regarding photoelectric effect. This photoelectric effect, when we consider, the major formula is only one, that is H nu is equal to W naught plus half mv square, that is actually the kinetic energy of the emitted photoelectron. This, in other words, we can even write like this also, H nu is equal to H nu naught plus half mv square, where nu naught is called threshold frequency. That is actually the name what we give to this. It is the minimum frequency of the incident photon needed for a photoelectron to be emitted from the surface of the cathode. The same equation can even be rewritten this way, H nu is equal to H nu naught plus E V naught. This V naught is called stopping potential. This is one more formula you just have to remember. So, stopping potential is directly proportional to the frequency over here. So, that is another obligation you have to remember. In fact, these are the cases you have to take up. And what is the general formula for work function? It is either H nu naught or Hc by lambda naught you can write, or a rough formula this way, that is easiest one, 12,400 by lambda taken in angstrom units. If you take lambda in angstrom units, W naught you will be getting in electron volt. That is actually the second stage of this particular chapter you have to remember. So, these are the formulae one should remember as far as photoelectric emission that is concerned. Now, come to the next one, that is regarding X-rays. X-rays, mainly we have only one formula, that is EV, that is the energy gained by the electron, will now be in the form of half mv square, that is kinetic energy of the fast moving electron. That only will be converted into an X-ray, that means H nu. That only can be written as Hc by lambda, because nu can be written velocity of light by wavelength lambda. That only can be rewritten this way, 12,400 by lambda taken in angstrom units. Thereby, the option what we will get will be in electron volt. This is the chain of equations you need to remember to solve any problem on X-rays in particular. This is the concept we have to take up. Now, come to the next one here, that is regarding Compton effect. One point you have to remember in this case is, what is Compton shift? You can all understand this general formula, delta lambda, which is lambda dash minus lambda, H by m naught c into 1 minus cos phi. That is actually the formula what we used to take up. And of course, we can all understand well, if theta becomes 0, cos 0 is going to be 1, then we will be finding delta lambda will be 0. If at all I consider theta is becoming 90, sorry, cos 0 is 1 directly, theta is 90 degrees, then okay, we will be getting this delta lambda as H by m naught c. This is itself what we call it as Compton wavelength. Right? What is this Compton wavelength? It is the Compton shift when angle of scattering is going to be 90 degrees. I hope we have taken here phi, therefore here also I write phi, so that there should not be any confusion for the students generally. H by m naught c, that is the concept. Now, what is its value? 0.0242 angstroms. Remember this value directly so that you can avoid this calculation in the problems. Come to the next one. If at all phi becomes 180 degrees, then of course you people can all understand well, this becomes delta lambda becomes twice H by m naught c. This is what we call it as maximum Compton shift. That is actually the concept. So, what is the relation between maximum Compton shift and Compton wavelength, please? Maximum Compton shift is twice the Compton wavelength. So, what will be the Compton shift maximum value here? 0.0484 angstroms. Twice of this value. Directly remember this one so that you need not calculate this value. No simplification is needed. Directly you can put that value there. Coming to the last one over here. What is the concept of de Broglie's hypothesis? What is the only formula we have? In fact, a small chain we are having. De Broglie wavelength lambda is equal to h by mv. This in other words h by p we can write. In other words root of 2m into kinetic energy. In other words h by root of 2m into qv. That v is going to be the potential difference and q is going to be the charge. If you can remember this chain of equations, any problem that comes on de Broglie's hypothesis, one can easily solve that one. So these are the major formulae one should remember before taking up this chapter, atomic physics as such. So let us now start working out the problems based on different models on this. One more point before that, before taking up the problem, I just want to tell you. This is one particular chapter where calculations are a little lengthy. So what you have to do at Eamcet level is, wasting your time unnecessarily in calculating till the last is not good. So what we have to do is rough estimation, that is rough calculation you make it, even though the calculation is looking very lengthy, and whatever is the nearby answer you people are getting, that you adopt, that you opt for that one, 100% your answer is going to be correct and you will be given a mark for that. Don't unnecessarily waste your time in calculating very lengthy numbers over there, please. Right? So let us start the very first problem. 2 photons of energy, 2.5 electron volt and 3.5 electron volt fall on a metal surface of work function 1.5 electron volt. The ratio of kinetic energies of the photoelectrons emitted from the metal surface is. In fact, we know h nu is equal to W naught plus half mv square. That is the formula. This is what we call it as kinetic energy. So kinetic energy 1 is equal to h nu minus W naught. What is h nu that has been mentioned here? 2.5. And what is W naught that has been given? 1.5. So you can directly write this as 1 electron volt. And what will be the kinetic energy 2? Once again h nu minus W naught. This time 3.5 minus 1.5, that now becomes 2 electron volt. What is the ratio of kinetic energies of the emitted photoelectrons? That is the concept what has been asked in that particular problem. Therefore, it will now be 1 by 2. So what will be the ratio, please? 1 is to 2. That must be the corresponding ratio. So third option, that is going to be correct for this particular question number 1. Look at the second problem now. Calculate the wavelength of K alpha line for Z is equal to 31 when A is 5 into 10 power 7 heads to the power half for a characteristic X-ray spectrum. In fact, all of you are familiar. In the case of X-rays, we even have discussed the concept of Moseley's law. Square root of frequency of the spectral line is equal to A into Z minus B. That is the formula what is called Moseley's equation. Out of that one, Z represents atomic number and A and B they represent Moseley's constants. And of course, nu is the frequency. So what is this question here? Calculate the wavelength he is talking. So you can rewrite this one C by lambda. Nu is equal to C by lambda is equal to A into Z minus B. But all of you should understand, for K series means what? For K alpha, K beta, K gamma, K delta, all these K series space, K spectral lines, for all those values, the value of B will be 1. So remember that value carefully. He will not provide us this one in the examination. So what to write now? Square root of 3 into 10 to the power 8 by lambda is equal to, A is already given, it is 5 into 10 to the power 7 into Z value is given 31, B value is known to us as 1. So now we can write that one as 30. So this now becomes 150 into 10 to the power 7. That is equal to this much. Now square it upon both sides, please. Then lambda becomes 3 into 10 to the power 8 by 150 whole square, 15 is 225, right? Into this, of course, 2 more zeros. This 2 for 10 to the power 14. So 10 power 16 we can directly write. Now simplify this whole lot. Whatever the value of lambda you are going to get, that will now be the corresponding wavelength of K alpha line. That now comes to be around 1.33 angstrom units. That means you will be left with 1.33 into 10 to the power minus 10. That 10 power minus 10 is automatically called 1 angstrom. That is a conversion what every one of us we know. Therefore, this simplified value will now come to be 1.33 angstroms. So, first option is going to be correct as far as this question is concerned. But remember this equation as Moseley's equation, which of course also is equally important in this chapter called atomic physics under X-rays part. Look at the next number, that is question number 3. When light photons of energy 4.2 electron volt is incident on a metallic sphere of radius 10 centimeter and work function 2.4 electron volt, photoelectrons are emitted. The number of photoelectrons liberated before the emission is stopped is how much? That is the concept. He is now talking about number of photoelectrons emitted before the emission is stopped. That means at a stopping potential, that is the concept. So, he has given you H nu value as 4.2 electron volt, first value. And work function of course he has given you as something like 2.4 electron volt. So, by looking to these two, can't you just calculate using this formula W naught plus EV naught, that V naught is called stopping potential here. So, I can write this way, EV naught is equal to H nu minus W naught. H nu is 4.2 minus 2.4. 4.2 minus 2.4, it now becomes 1.8. So, directly what? 1.8 electron volt. So, you can all understand this implies what is this stopping potential. Stopping potential is nothing other than V naught here. E getting cancelled, that V naught now becomes 1.8 volt. That is actually the stopping potential. At this potential, what is it observed? The photoelectric emission automatically will be stopped. No photoelectron is going to be emitted from the photocathode after reaching this particular potential, which is to be called stopping potential as such. But his answer is not this. His question is not at all this one. He is asking you number of photoelectrons liberated before the emission is stopped. Now, we all in fact know what is the formula for electric potential. 1 by 4 pi epsilon naught into Q by R. That is actually the formula for potential. That potential, now you take it as a stopping potential. Another thing, you can even rewrite the same 1 by 4 pi epsilon naught into n times the charge on an electron by R. So, what is what out of that one you can understand now. 1.8 is equal to 9 into 10 power 9, that is the value of 1 by 4 pi epsilon naught, into n into 1.6 into 10 to the power minus 19 coulomb, that is the charge on the electron, whole divided by what is the value of R given, you see 10 centimeter given, that you better write 0.1 meter. So, out of this entire equation, n is the only value which is not known to us. In fact, you can cut this decimal and this decimal here, and 10 power 9 cancels here minus 10 times. So, what will be the value of n now? 1.8 divided by 9 into 16 into 10 to the power minus 10. Simplify this whole lot, and whatever the value you are going to get, that will now be the number of electrons which are now going to be rather produced before the stopping potential has been attained. So, what will be the correct option you will be getting from this one? You will be getting 1.25 into 10 to the power 8 number of electrons which are going to be liberated from the system. So fourth option is going to be the correct option. But look at how that personality has given a linked up question. This actually is from photoelectric emission. This equation is from electrostatics. He has linked this chapter with electrostatics in one of the recently completed Eamcet examinations. That means, of course, just 2 years back, he has asked the same question there. Look at the next number, please. The question number 4 this time. In Thomson's experiment, to determine E by M of an electron, it is found that an electron beam having a kinetic energy of 45.5 electron volt remains undeflected when subjected to crossed electric and magnetic fields. If electric field strength E is 1 into 10 power 3 volt per meter, then the value of B is how much? Of course, he has provided us the mass of an electron also, 9.1 into 10 power minus 31 kg. Just look at what he is talking about. Electron beam is undeflected. That is the first concept. Electron beam is undeflected means what is the condition I have given you? Velocity must be equal to electric field strength by magnetic induction. E by B, that is actually the formula for us, right? And of course, what is the value of velocity? That is the thing we have to take. V is equal to under root 2 EV by M. All of us, we know very well half mv square is equal to EV formula. Now you can write this one 2 times. What is the value of energy he has given you? 45.5 electron volt. 1 electron volt is 1.6 into 10 power minus 19 joule. By mass is 9.1 into 10 power minus 34. Take under root. Whatever the value you are getting from this one, in fact 2 into 45, 90. 90 plus 1, it will now be 91. And of course 10 power minus 19 cancels here minus 15 times. So this decimal and this decimal you can cancel that one off. 91 into 16 by 91 into 10 to the power 15 whole under root. You can write this one. You can cut this one over here. And of course, you are finding that this 10 power minus 15, it's 15 is there. So you can write directly this as root of 16 into 10 to the power 15. Keep it like that. Afterwards, finally, you can calculate. There is nothing wrong. So this value, you substitute it here. What is the value of B we want? It is E by V. What is electric field strength mentioned that one? 1 into 10 power 3 he gave. By the value of V, whatever you are getting here, come on, write that one and simplify the total lot. You will be now left with 2.5 into 10 to the power minus 4 Weber per meter square. That is the answer you are going to get. So one thing you should understand here, it is 2 EV by M under root is the formula for velocity. First formula what we are applying is that, and velocity must be equal to E by B for the undeviation of an electron from its original path. So based on these two, you can simplify the value whatever is required, that is the magnetic induction field required over here. Look at the next problem, problem number 5 this time. Photoelectric emission is observed from a metallic surface for frequencies nu1 and nu2 of the incident light. He has given nu1 is greater than nu2 is the condition. If the maximum values of kinetic energy of the photoelectrons emitted in the two cases are in the ratio 1:n, then the threshold frequency of the metallic surface is how much? That is the concept. Once again the same old formula what we have discussed. That of course H nu is equal to W naught plus half mv square, that is kinetic energy. That's what actually he is talking about. And frequencies he has given, kinetic energy ranges he is talking about. So you write the first equation, H nu 1 is equal to W naught plus kinetic energy 1. You can in other words write the same, kinetic energy 1 is equal to H nu 1 minus W naught. What is the second equation? H nu 2 is equal to W naught plus Ke2 I now can rewrite the same. Ke2 is equal to H in U2 minus W naught. That is actually the concept. Fine. Now the question is kinetic energy 1 by kinetic energy 2. That of course I can write H in U1 minus W naught by H in U2 minus W naught. This is the equation generally. But what is that he has given you? This is equal to 1 by N he gave. That is actually the concept he has mentioned there. So if you just cross multiply this one and calculate the value of work function, first and foremost what we can do here, N times H nu1 minus N times W naught is equal to H in U2 minus W naught. Of course, nu1 is greater he is talking about. Therefore, bring this one this side. H into N nu1 minus nu2 is equal to this going that side W naught into N minus 1 you are left with. So, what will be W naught now? H into N nu1 minus nu2 divided by N minus 1. Fine. But W naught can be written as H by lambda naught or H nu naught we can write. His question is what is nu naught? Therefore, H gets cancelled. What is left over now? You check it. Nu naught will now be equal to N nu1 minus nu2 by N minus 1. Look at this particular option, which one is given there? Second option is exactly tallying with this. So, second option is the correct option for this question number 5. Okay, look at the next number, that is problem number 6. The surface of a metal has work function 2.66 electron volt. This is illuminated with photons of wavelength 450 nanometer. The de Broglie wavelength of the emitted photoelectrons is how much? Mass of the electron as usual has been given there. Look at once again what is the data mentioned there. He is talking about work function 2.66 electron volt. That is the first value provided to us. What next he has given? It is illuminated with photons of wavelength 450 nanometer. Wavelength 450 nanometer means 4500 angstrom units. You can convert this one into angstrom unit over there. Now, what is the advantage of writing this angstrom unit? What will now be the value of energy? H nu can be written as 12,400 by lambda taken in angstroms. That's what I have already told you. So, you can write 12,400 by 4,500. Come on, cut this one. Now, roughly you take this one as 125, 9 times 5 and of course here 25 times 5. So, what is roughly you people are going to get here? 2 times 2 9 is 18. Okay. Now, 70 is left around 7 times. Right, around 7, 2.7 near around electron volt we can think of, right. Now, the concept is from this you subtract this value, then what will you get now? This is W naught, this is H nu. So, half mv square will now be equal to H nu minus W naught. So, whatever the value you are getting around 2.7 minus 2.66 like this, you can get it. That value will now be the kinetic energy. But what is he asking? De Broglie wavelength we want. So, this kinetic energy, you can even write that one in electron volt like this. Now, what is the de Broglie wavelength formula? H by root of 2m into kinetic energy. That is the formula. So, what we should write now? H value 6.6 into 10 to the power minus 34. What is the value he has given you for H? Of course, he has not mentioned. So, directly you can take 6.6 into 10 power minus 34 divided by 2 times mass he has given you 9 into 10 to the power minus 31 into what is the kinetic energy value you are getting? It is 2.7 minus 2.66. What? Electron volt into 1.6 into 10 power minus 19. That totally this value should be under root. This if you simplify, you will be getting the value near around 4, that is 4.09 into 10 to the power minus 9 meter you will be getting. But see the way he has asked a question, very lengthy calculation. Calculation is of course here one part we people are taking up. This calculation it takes its own time, but rough calculation will certainly help you, because if you look at the options, no two options are similar or nearby. Therefore, one option which is directly nearby to our answer, you can take that one for granted. So second option is the correct option for this question number 6. Look at the next number, that is problem number 7. The work function of a certain metal is 3.31 into 10 power minus 19 joule. Then the maximum kinetic energy of photoelectrons emitted by the incident radiation of wavelength 5000 angstroms is how much? Maximum kinetic energy of emitted photoelectron. Directly you can write the formula half mv square, that is kinetic energy, is h nu minus W naught. What is h nu? How to just take that one? Maximum kinetic energy of photoelectrons emitted by the incident radiation of wavelength 5000. You take 12,400 by 5000 you take here. 2 zeros you can cancel. And what is the value of W naught that has been given here? 3.31 into 10 power minus 19. 3.31 into 10 power minus 19 divided by 1.6 into 10 power minus 19. I am converting this value into electron volt. So you will be getting the total answer in terms of electron volt. How much you will be getting? Near around 0.41 electron volt you will be getting. So very simple, this you write directly in electron volt, this you convert it into electron volt. The difference between these two, that only gives you the kinetic energy of that emitted photoelectron as such. So around 0.41 electron volt will now be the corresponding answer for this second option, that's going to be tallied for this question number 7. Look at the next one, that is problem number 8. Electrons accelerated by a potential of V volt strike a target material to produce continuous X-rays. Ratio between de Broglie wavelength of electrons striking the target and the shortest wavelength of continuous X-rays emitted. What is the ratio of these two wavelengths he is asking. First of all, what is de Broglie wavelength of electron? Lambda is equal to h by mv. You can write this one as h by root of 2m into EV. This V is called potential difference that has been given in the problem as capital V. So this is the first one. This is lambda of electron. Remember that. And what next he is asking? Shortest wavelength of continuous X-rays. You all know EV must be equal to hc by lambda. That's lambda is of what? Lambda of X-ray. Remember this point. Then can't we write once again lambda of X-ray is equal to hc by EV, please? That is the second equation. Now his question is, what is the ratio between what? De Broglie wavelength of electron and wavelength of emitted continuous X-ray. So take the ratio, please. Lambda of electron divided by lambda of X-ray. That is actually the thing what he is asking. So write h by root of 2m into EV divided by, that means EV by hc. H gets cancelled. You can directly understand lambda is equal to hc by EV. That is actually the formula what we people are having. hc by lambda directly we have taken up, right? Now you directly take these things inside. Then what can we write? 1 by c, you keep it outside. Root of, take this one into it, please. E square V square by 2m into E into V. One E gets cancelled, one V gets cancelled. Now what is left over, you see? 1 by c root of EV by 2m. Which one is coinciding with this option? You check that one. 1 by C root of VE by 2M. That is the third option, which is the correct option for this particular question. Wonderful model question it is. Two different wavelengths he is asking you to compare. So that is question number 8 and option is 3 for that. Look at the next one, that is problem number 9. In Millikan's oil drop experiment, a charged oil drop of mass 3.2 into 10 power minus 14 kg is held stationary between two parallel plates 6 mm apart by applying a potential difference of 1200 volt between them. How many electrons does the oil drop carry? What is the general condition for an oil drop to be at rest in space? The simple concept over here is weight of the oil drop must now be compensated by force due to electric field. That is actually the formula one has to remember. What is weight in general? mg. What is force due to electric field? E times q. But of course E has not been mentioned there. You can definitely understand E can be written as V by D into Q. V for potential difference, D for the distance of separation between the parallel plates. So we can directly understand now from this one, Q is the total charge. Total charge means how to write that one? It is N times the charge on each electron. So N is the value what we want. So N is equal to, cross multiply this one, mg D by V times E. That is the final formula. What are the values he has given you? Look at now, 3.2 into 10 power minus 14. That directly he has given you in kilogram. Into G. G value is mentioned in the problem as 10. Fine. What is the distance of separation? 6 millimeter apart. 6 into 10 power minus 3 meter apart. V is given 1200 volt. Directly you can write charge on an electron as 1.6 into 10 power minus 19. Look at carefully, 10 power minus 14 minus 3, that is minus 17. This goes minus 2 times. These two zeros and this 10 power minus 2 gets cancelled. 1.6 goes twice here. So this 2 cancels here 6 times here. This 6 and this 6 they get cancelled. Ultimately what is left over, you just look at. Simply 10 is left. So how many electrons are there on the drop now is the question. 10 electrons are there on the drop, which now coincides with fourth option for this particular question number 9. Look at the next one, that is problem number 10 please. In X-ray spectrum, transition of an electron from an outer shell to an inner shell gives a characteristic X-ray spectral line. If I consider the spectral lines K beta, L beta and M alpha, K beta, L beta and M alpha, then what is the common feature there? Look at one point. First and foremost, you should understand what exactly is the characteristic X-ray spectrum. If I just take, this is K shell, this is L shell, this is M, this is N and so on like that if we imagine. If the transition of electron takes place between L and K, whatever the spectral line we people are getting is called K alpha line. Remember this concept thoroughly. If at all the transition is taking place from M to K, that is called K beta. If at all the transition is taking from N to K, K gamma, K delta, K epsilon and so on, this is what is called K series spectral lines. Now suppose if I take from M, if the transition takes place into L, this is called L alpha. From N, the transition if it is taking place into L, that is called L beta. Exactly like that, from N, if the transition takes place here to M, this is what is called M alpha. Now what he has given you in the problem, K beta, L beta and M alpha. These three he has asked us to compare them. Okay, if you compare them, what is the concept? Are you not observing L beta and M alpha have got the same outer orbits please? That is the answer 3. L beta and M alpha have a common outer shell. That is the corresponding answer. But remember, K beta the first line, L beta the second, M alpha the third. These three have been compared. This question has been asked in one of the Eamcet papers. So, very important model. It is a very simple one to identify. Suppose if they ask you K beta and L alpha, they also do have the same outer shell. So, likewise, which one is having a common outer shell, which one is having common inner shell, like that type of questions can be asked over here. So, for this particular question, the option must be the third one, which of course L beta and M alpha both have the common outer shell as such. Look at the next problem, that is problem number 11. The de Broglie wavelength of an electron and the wavelength of a photon are the same. The ratio between the energy of that photon and the momentum of that electron is how much? Directly you people can understand what is the thing he is talking about. De Broglie wavelength of an electron, lambda is equal to h by mv. This in other words you can write h by p. That is the first equation. What next he is giving you? The second one is wavelength of a photon. Wavelength of a photon in the sense h nu, right? Energy is equal to h nu. That of course you can write this way, hc by lambda. That means what will be the wavelength of photon over here? Lambda is equal to c by nu. That is the concept. These two of course are going to be same like he is talking. In other words, you can even write E is equal to mc square also. From this also you can identify it is momentum into c. Now what is energy by momentum? It is equal to c. Like that also you can write, but according to the values given I am talking about. So what will be the value of lambda? Lambda can be written in terms of hc also. Lambda is equal to this value of hc by E. That is actually the point. Right? E is equal, that is in other words you can write lambda is equal to c by nu. That is also the way we people used to represent. This is a better choice to write that one. H lambda is equal to c by nu. C is equal to nu lambda. Now what is the ratio? He is asking you what ratio he wants in fact. What is momentum? It is h by lambda. And what is the value? Second one he is talking about. These two wavelengths are equal. Wavelengths are equal means what we can write? H by P is equal to C by nu. Now what is his question actually? The ratio of between energy of that photon and momentum of that electron. What is energy of photon please? H nu. That can be written as hc by lambda. So lambda can be written hc by E. This is actually the energy of photon, that lambda is equal to that. So h by P is equal to hc by E. That's what he is talking. Now come on, h gets cancelled. Momentum by energy is how much? Energy by momentum. Is it not equal to C please? E by P is equal to C. So what will be your answer over there? It should be equal to the velocity of light. That means the second option is going to be correct for this. But all these conversions you people should be thorough with. Then only you can do this type of a model. Look at the next problem, that is problem number 12. Right? Delta lambda is the difference between the wavelength of K alpha line and the minimum wavelength of continuous X-ray spectrum when X-ray tube is operated at a voltage V. If the operating voltage is changed to V by 3, then the above difference is delta lambda dash. Then what is the relation between these two? That is the concept. You should understand first and foremost what is the h nu is equal to EV. You can write the same thing this way also. Hc by lambda is equal to EV. So can't you now understand V is inversely proportional to lambda please? So in other words I can write this one only like this. V is inversely proportional to 1 by delta lambda please. So we can write V1 by V2 is equal to delta lambda 2 by delta lambda 1. Now what is V1 given? It's V. What is V2 given? It is V by 3. That is equal to delta lambda 2 by delta lambda 1. In other words, you can say the same thing, delta lambda by delta lambda dash is equal to V by 3 by V. That means, is it not 1 by 3, please? So look at that one carefully now. If you cross multiply this one, delta lambda dash becomes 3 times delta lambda. But one should understand a very simple concept. Since work function also is included over here, this delta lambda dash will not be exactly equal to that. It will be a little less than that value. So what is the correct option for us? The fourth option is going to be the correct option. Delta lambda dash is less than 3 times delta lambda. That is actually the concept what you have to take up. Look at the next problem, that is problem number 13. Electrons ejected from the surface of a metal when light of certain frequency is incident on it are stopped fully by a retarding potential of 3 volt. What is this retarding potential here? That is what is called stopping potential. That V0 he has given you simply 3 volt. That is the value he has mentioned first. Photoelectric effect in this metallic surface begins at a frequency 6 into 10 to the power 14 hertz. You can understand this one is called nu naught. 6 into 10 to the power 14 hertz. This is what is called threshold frequency. And what next he is asking you? What is the frequency of incident light in hertz as such? So H nu is equal to H nu naught plus EV naught. That is the formula. So what can we write from this? Nu is equal to nu naught plus EV naught by H. That is the formula. What is nu naught given? You see here 6 into 10 to the power 14 plus charge on the electron 1.6 into 10 power minus 19 into what is V naught that is given? It is 3. All divided by what is the value of H given? You see carefully 6.4 into 10 power minus 34. First and foremost cancellation is this cancels here minus 15 times and this cancels here 4 times. Look at now 6 into 10 to the power 14 plus 3 by 4. 3 by 4 is 0.75 into 10 to the power 15. In other words, you can even write the same 6 plus 7.5 into 10 to the power 14. So 6 plus 7 is 13. 13.5 into 10 to the power 14 will now be the corresponding answer for you. Look at the options carefully, please. Third option must be the correct option for you. 13.5 into 10 to the power 14 what? Since it is the frequency, that will be in hertz as such. So that is the question number 13. Look at the next number, that is problem number 14, please. K1 and K2 are the maximum kinetic energies of the photoelectrons emitted when light of wavelengths lambda 1 and lambda 2 respectively are incident on a metallic surface. If lambda 1 is equal to 3 lambda 2, remember lambda 1 is 3 times means K1 should be less than K2 by 3 times. In the sense K1 should be less than K2 by 3. Look at those options, please. The very first option is given and second option will be the correct one. Since lambda is becoming 3 times, K becomes 1/3. That in fact in what manner? It should be a little less than that. So K1 should be less than K2 by 3. That is the corresponding option. No calculation that is needed for this question in fact. Look at the next one, that is problem number 15. Light rays of wavelength 6000 angstrom and of photo intensity 39.6 watt per meter square is incident on a metal surface. If only 1% of photons incident on the surface emit photoelectrons, then the number of electrons emitted per second per unit area from the surface will be how much? That is the concept. He is giving us intensity there. Intensity in what manner he has given you? 39.6 watt per meter square. That is per unit area, it is power by area. That is actually the concept you have to remember. Now, this can be written directly this way, Hc by lambda. we are having. For each photon it is hc by lambda. Let us say n photons we shall take up. N times hc by lambda must now be equal to this value of p. So what will be n now? N must be p into lambda by hc, but only 1% is going to be emitted in terms of photoelectrons. So what you have to write? 1% means 1 by 100. What is p given? 39.6 into lambda, how much it is given? 6000 what? Angstrom units you can write. Whole divided by this 100 is very much there into h value he has provided you, that is 6.64 into 10 to the power minus 34 into velocity of light, of course is known to all of us, 3 into 10 power 8 meter per second. If you simplify the total lot, you will be getting a number. What will you get over here? Around 12 into 10 to the power 17 electrons are going to be liberated from the system. 12 into 10 power 17, you can directly understand that option is going to be the third option. But here itself we can decide that value almost. This goes up naturally 10 power 14. Right, and of course if you directly look at that one, it comes to be 12 into 10 power 17, easily you will be getting that one. This number is going to be the number of electrons which are liberated in this particular case. This also has been one of the Eamcet questions, please. Look at the next problem, that is problem number 16. When radiation of wavelength lambda is incident on a metallic surface, the stopping potential is 4.8 volt. If the same surface is illuminated with radiation of double the wavelength, then the stopping potential becomes 1.6 volt. Then the threshold wavelength for that particular metal is how much? That is the concept. All of you can understand hc by lambda is equal to W naught plus EV naught. What is that EV naught here? 4.8 EV. That is the concept. Now of course from this one you can directly write that W naught, of course this is the first equation, afterwards only you can simplify that one. Second time what he said, when the wavelength is doubled, then we people are getting 1.6. So hc by 2 lambda is going to be W naught plus 1.6 electron volt. That is actually the concept. Now if you just simplify these two and calculate W naught, you will be getting W naught. What is W naught? He is asking you what actually? Threshold wavelength. hc by lambda naught you will get. After getting that one, lambda naught is equal to hc by W naught. If you simplify this whole lot, you will be getting that lambda naught is going to be exactly 4 times lambda. So correct option in this particular case is supposed to be the second option, please. So simplify these two equations. Simplification of course depends on you how best you do it. You can directly write hc by lambda this value here and equate the value W naught you calculate. Then you finalize the value of lambda naught from that. So directly you will be getting 4 lambda. So second option is correct option for this question number 16, please. Look at the next one, that is 17. When an X-ray tube is operated at a constant potential difference and it is required to get X-rays of wavelength not less than 0.2 nanometer, then the potential difference in kilovolt is how much? Direct application here. EV must be equal to hc by lambda. So what is the value of V we want? H value he has given you 6.63 into 10 to the power minus 34 into C 3 into 10 to the power 8 whole divided by the value of E 1.6 into 10 power minus 19 into the value of lambda, that is given 0.2 nanometer into 10 power minus 9. Whatever the value you get in volt, you can automatically convert that one into kilovolt by dividing it by 1000. What exactly you will be getting for this? 6.2 kilovolt you will be getting. So exactly the option is going to be the third option for this particular problem number 17. Look at the next number, that is problem 18, please. 2 photons of energies twice and thrice the work function of a metal are incident on a metal surface. Then the ratio of maximum velocities of the photoelectrons emitted in the two cases respectively will be. 2 times energy, 2 times the work function. So 2 W naught is equal to W naught plus half mv1 square. That is the first equation. So can't you write half mv1 square is equal to W naught, please? That is your first one. What is the second one? 3 times W naught is equal to W naught plus half mv2 square. Therefrom I can write half mv2 square is equal to 2 W naught as such. Now come on, divide 1 by 2. V1 square by V2 square will now be 1 by 2. Then what will be V1 is to V2, please? 1 is to root 2. So what is the correct option that is tallied? Fourth option is going to be tallied for this question number 18. Look at the next number, that is problem number 19, please. In Compton scattering process, the incident X radiation is scattered at an angle 60 degrees. The wavelength of the scattered radiation is 0.22 angstroms. The wavelength of incident X radiation will be how much? You know very well, lambda dash minus lambda is h by m naught c into 1 minus cos phi. That is the case. Now he has given you the value of lambda dash. How much he is giving you there? 0.22 minus lambda. H by m naught c value, you know, 0.0242. Of course, he has given 024 into 1 minus cos 60. Cos 60 is half, so it will be 1 by 2. So what will be the value of lambda now? 0.22 minus 0.012. What will be the value you are going to get? 0.208 angstrom units you will be left with. So which is the correct option there? The fourth option is the correct one for this 19th problem, please. Look at the next one, that is 20th question. If lambda naught is de Broglie wavelength for a proton accelerated through a potential difference of 100 volt, the de Broglie wavelength for alpha particle accelerated through the same potential difference is how much? De Broglie wavelength in terms of potential difference, lambda is h by mv. This can be written as h by root of 2m, that is m into, that is mv means you can write 2m into qv, you can write. Now what is de Broglie wavelength when the potential difference is same? Then you can write lambda proton by lambda alpha particle is equal to root of mass alpha particle by mass proton into charge on alpha particle by charge on proton. What are these values? Look at mass of alpha 4 units, proton 1 unit, charge of alpha 2 units, proton 1 unit. Root 8 you are getting. That means what will be lambda alpha now? It is lambda proton by root 8. Root 8 can be written 2 root 2. Now look at the option, please. Lambda by 2 root 2. That of course he has given you lambda naught by 2 root 2 in the problem. So which option that is tallied you look at? The third option is tallied for this question number 20, please. Look at the last number in this order. In Compton scattering, X-rays of 1 angstrom are scattered from carbon block of which Z is 6 and zinc block of which Z is 30 at 90 degrees with incident beam. The ratio of scattered wavelength will be. All of you should understand the equation thoroughly here. Compton wavelength delta lambda, lambda dash minus lambda, h by m naught c into 1 minus cos phi. All of you observe carefully, h, m naught c, all the three are constants. Excepting phi, delta lambda does not depend on anything else. Remember carefully, in this equation, there is no atomic number term at all. There is no z term at all. That means what? Delta lambda is independent of z. That is the point which is called atomic number. So whether z is 6 or z is 30 hardly matters. Phi, if it is constant, the value of delta lambda must be the same. So what we should understand here, the wavelength variation delta lambda 1 is to delta lambda 2, whatever you talk about, or the wavelength ratio is supposed to be 1 is to 1. So what is the question he has asked? You see there, the ratio of scattered wavelengths will be how much? 1:1, because delta lambda does not depend on Z, it simply depends on phi only. In both the cases, phi is given 90 degrees only. Remember that part. So which is the correct option for us? Third option, which is 1:1, must now be the correct one. So these are the models what we people are having as far as atomic physics part that is concerned. Therefore, even though calculations are a little lengthy, don't leave them in the exam. Try to work them out roughly and estimate the correct answer over there. Right? And in the same order, we people are left with nuclear physics and semiconductor physics of second year. That of course we people are going to discuss in the next session.